So, what are ARM templates and in what use cases might we want to use them? Let's take a practical dive into how to deploy them as well as how to troubleshoot. So here I've got a production resource group and I've got a few services that I'm running, and I'd like to use ARM templates now to recreate a QA environment for this. So what I'll do is I'll go to export template, and right now I've gone in with the context of the resource group, but if I went to a specific resource, it would only show the ARM template for that specific resource. Now this will show the ARM template for the entire resource group. Now, resource ARM templates or Azure Resource Manager templates are useful because they're infrastructure as a code, and you'll see it's a JSON notation which allows us to define what our infrastructure should look like, and that way we can repeat it. It's a declarative approach. If you think of like DSC or desired state configuration, it allows us to say this is what it should look like. And it's idempotent, which means it can be applied over and over and we'll get the same results. To use this now, I'll hit the download button over here, and opening up the two files, it's a template.json file and a parameters.json file. The template.json file defines which parameters this template uses, and the parameters.json file is something your pipeline or your script would use to fill in the values to run the script. So you could have multiple parameters.json depending on maybe your environments. In our case, we'll change all of these to QA. And I'm actually going to create a very long name over here to cause an error and to help also with troubleshooting. Let's quickly take a look at the template.json file though. And over here, you'll see these are all the resources that we've now defined. And because we used the entire resource group. And what I specifically want to show is that there are so many ways we can use this. It's very rich in flexibility. It can get quite complicated, but there we can do concatenations, we can do parameters and variable lookups. Another interesting thing as well we can do is, for instance, here, I'm listing the keys to the storage account I've just created, potentially just above. So what this means is I can both create the storage account and reference its key to create a connection string in the same template without having to first create it, kind of get the ordering right. So we can also use depends on those kind of things to make sure that when we run it in the correct order. The resources that depend on each other will be there, and that is repeatable and consistent. So I've created a little deploy PowerShell script. It's just using AZCLI. And if you have a pipeline already, like for instance, Azure DevOps Pipeline's got some nice functionality for setting up ARM templates, and you can just follow the wizard there. If you're using AZCLI, you need to make sure that you're logged in. I'm already logged in. And then what you can do is you can set the subscription. This is just the AZCLI thing to make sure we're in the right subscription. And thereafter, so our aim is to create a QA resource group. So we'll do that. This is something you'll only run once though, because if you're deploying over and over and aligning the resources, you wouldn't create a resource group every time. So this is a once-off. And now you'll see that our ARM template QA has been created. Right now it's got nothing inside, no deployments. And so let's create that deployment. Back in AZCLI, so this is the command that you would run. And the resource group over here would be -QA. And template file points to the template JSON. And then we've got the parameters file, parameters.json. Let's run it. Now this was expected because we did make the storage account name too long. But you'll see this is the reason I wanted to show this, is because this message isn't very clear. And this is something you will encounter, especially with more complex ARM templates in the validation phase. So the template deployment, that's just the deployment name we've given it, is not valid. And you'll see it's a pre-flight validation check. So let's go see where we can find this error. Now when you run an ARM template, you'll see it actually creates a deployment. And but before it creates a deployment, it first does a validation check. Now the validation check failed, so we can't see anything in deployments. If the deployment started, we'd go in here and we'd see why the failure. But in this case, the deployment hadn't started the validation before the deployment failed. So let's go to activity log, and this will show that the validation had failed. So let's go in here and we can see the same message that we saw, but if we go into the JSON, there's a little bit more detail here. Bad request, and if we have a look, we'll see that this is not a valid storage account name. Storage account name must be between so and so many characters. And I once again, we did this deliberately because troubleshooting can be quite hard if you don't know where to look. So that is quite important to know. So let's make it shorter and run it again. And that ran for a couple of minutes, and once that was done, we can go to the portal. And what you'll see now is under deployments, we'll see that there's one succeeded. So let's take a look, and everything is working nicely. So it's all green, and all the steps within the ARM template were deployed successfully. And so now if we take a look at the resource group itself, look at the resources, we've got the resources we've defined, which exactly matches our production environment. And except for the naming is slightly different, that's because we parameterized that. And of course, we can parameterize almost anything that we want to differentiate between the environments. And then just to take a look at the configuration as well. So over here, you'll see the storage connection string. If we go in here, you'll see the account key is set and our full connection string is here. And remember, this account key is from the storage account, which was created in the same run or the same deployment. And it's just based on the ARM template that we could reference that. And so if we go into secret key, we'll see this is the QA password. What I didn't mention earlier is that the super secret key that we saw came from Key Vault, and it wasn't a value that we set explicitly. So over here, we see the parameter is my secret key. And if I look at the parameter, we have the ability to say that this comes from this Key Vault with that secret name. Jumping to the instance in Azure, the Key Vault instance, this is something you can lock down so that only certain people have access to it. And over here, we see that key that's been defined, my secret QA. In there, I can see the value, and that's where the value came from. And what is quite important to note, if we are using Key Vault in an ARM template, we have to define the access policy. And there are two things here. The first is you have to say that an ARM template is allowed to access this. So this must be checked, which isn't by default. And then the second thing is who is the user that runs the script or the service principal that runs it from the pipeline, for instance. That user or a principal needs access to, in this case, secrets permissions. I've got access to a lot of things here, but you would want to go with the least privileged principal and only allow a get, for instance, on the secrets. And that way your pipeline is able to use the parameters, has access to the Key Vault, get the key, deploy it, and potentially none of the developers would have access to this key. And that's it. So if you're used to something like Terraform, you'll see that it seems a lot more complex, the notation. And more recently, Microsoft has introduced Bicep, which the name is quite fitting to ARM, and it has a notation that's very similar to Terraform as well. So I'll be looking at those two and comparing the pros and cons between ARM, Bicep, and Terraform in another video.